Find the radius and the interval of convergence for the power series x plus 2n over n square 3n. By the way, x plus 2 is same as x minus negative 2. Okay, so negative 2 is the center for this power series. So center A is negative 2, and we know that any power series converges for x equals center, x equals negative 2. In this case, this power series converges for x equals negative 2. So for other x's, when x is not equal to negative 2, let's find the following limit of a n plus 1 over a n when n goes to infinity. Let's limit n goes to infinity of a n plus 1. By the way, this is a n, so a n plus 1 would be replace n throughout by n plus 1, so that's x plus 2 raised to n plus 1 over n plus 1 squared times 3 raised to n plus 1, that's a n plus 1 divided by a n. A n is given here, x plus 2 raised to n over n is squared times 3n. Okay, let's continue this limit. X plus 2 raised to n plus 1, let's factor so that we can cancel with this. X plus 2 to the n times x plus 2 raised to 1. Okay, 1 we don't have to write, over n plus 1 is squared. Let's do the same thing, let's factor. 3 raised to n plus 1 is same as 3 to the n times 3 to the 1, or just 3. Let's change division into multiplication. We need to flip this fraction, so n is squared 3n over x plus 2 to the n. Okay, now we can cancel a couple of things, this one, and 3n cancel. Okay, so we use the fact when we have x raised to a plus b, that is same as x raised to a times x raised to b. So here and here, so that we can cancel. Okay, now next let's look at the limit. X plus 2 n square on the top, 3 n plus 1 square on the bottom. This is limit for n goes to infinity. So x plus 2 and 3 are independent of n, so we can pull all the way outside with absolute value. So absolute value of x plus 2 all the way outside, and absolute value of 3 all the way outside, and limit n goes to infinity of, what is left inside, n squared over n plus 1 quantity square. We don't need absolute value anymore because these are positive terms. Now let's find this limit. Okay, this infinite limit basically depends on the leading terms. N is square on the top, n plus 1 is square means multiply n plus 1 by itself, you get n is square plus 2n plus 1. Anyways, the leading term is n square cancels 1, so this limit is 1. Then we have x plus 2 over 3. Okay, so we found the limit of a n plus 1 over a n when n goes to infinity as absolute x plus 2 over 3, and we know by the ratio test the series converges if this limit is less than 1, and the series diverges when this limit is bigger than 1. So the series converges if this limit is less than 1. Maybe by the ratio test, let me write there, by the ratio test. Okay, the series converges if this is less than 1, and the series diverges if this is bigger than 1. This is same as multiply both sides by 3, we get x plus 2, let's write negative 2 is less than 3. Okay, multiply both sides by 3. Then this 3 is the radius of convergence. Radius of convergence. Okay, r equals 3. And let's look at the interval. This is the number line, and we have center of -2, and radius 3 means we can go up to 3. -2 plus 3, that's 1. -2 minus 3, so -5. So we now know the series, the given power series converges in between -5 and 1. Since the ratio test fails when this limit equals 1, we don't know what happens when x equals -5 and x equals 1. So we need to test the given series when x equals -5 and when x equals 1. Okay, so two individual cases. When x equals -5, the given series, the given power series becomes is equal to, let me see, n from, so x equals -5. Let's go up. N equals x equals -5. So x equals -5, -5 plus 2, -3n, -3n over n squared 3n, -3n over n squared 3n, n from 1 through infinity. Okay, let's simplify this series. N from 1 through infinity. -3 to the n is same as -1 times 3 inside, so -1 to the n times 3 to the n over n squared 3 to the n, and we can cancel 3 and from top and bottom. So this series becomes n from 1 through infinity of -1 to the n, and I'll write in this way, times 1 over n squared. Okay, this is an alternating series, due to -1 to the n. Okay, to test for convergence, all we have to show 1 over n squared decreases and it decreases to 0. Okay, 1 over n squared decreases for sure, because when n is big and big, the bottom gets bigger and bigger. So 1 over bigger and bigger is smaller. So 1 over n squared decreases. And when n goes to infinity, 1 over infinity is square, so it goes to 0 as well. All that means 1 over n squared is decreasing to 0. Then by the alternating series test, this one converges. So I don't write all the details. I would say which this converges by the alternating series test. That means -5 is included in the interval of convergence. Okay, now we want to test the right end point x equals 1. So let's do the same thing. When x equals 1, the given power series becomes n from 1 through infinity. Okay, so let's go up and see. So x plus 2, x is now 1, so 1 plus 2, 3n over n squared 3n. So 3n over n squared 3n. Now we can cancel 3n, and we have some n from 1 through infinity of 1 over n squared. Okay, which is a p series. This is a p series with p equals 2, bigger than 1. So this converges. Okay, this converges. Why? This is a p series and p equals 2 bigger than 1. See, and p is 2 bigger than 1, so converges. That means our interval of convergence also includes 1. So the power series converges for all values in -5 to 1, including 5 and -1. Oh, this is -1, so I made a mistake. No, that's, sorry, this is 1, -2, 3, 1. My bad. anyways. Thus the interval of convergence is now bracket including -5 through all the way to 1.